Welcome viewer. This video explains the concept and process of testing hypothesis for two-sample independent t-test. An independent t-test is a statistical method used to determine if there is a significant difference between the means of two independent groups. It's commonly used when you want to compare the means of two groups to see if they are significantly different from each other. Here are the key assumptions of the two-sample independent t-test. First is random sampling. The sample data should be collected through a random sampling method to ensure that it is representative of the population. Second is normal distribution. The sampling distribution of the sample mean should be approximately normally distributed. Third is interval or ratio scale. The data used in the t-test should be measured on an interval or ratio scale. Fourth is homogeneity of variance. The variances of the observations in the population should be equal. Fifth is independence. The observations in the sample should be independent of each other. This means that the occurrence of one observation should not influence the occurrence of another observation. Let's now discuss the steps for hypothesis testing using a two-sample independent t-test. First step is, formulate the null and alternative hypotheses. The null hypothesis usually states that there is no difference between the means of the two groups, while the alternative hypothesis suggests there is a significant difference between the means. Second step is, choose the significance level, alpha. Common choices for alpha include 0.05 and 0.01. This signifies the probability of rejecting the null hypothesis when it is actually true. Third step is, determine the critical region. Based on the alternative hypothesis and the significance level chosen, find the critical value or values from the standard normal distribution table. Fourth step is, collect data and calculate the sample mean and standard deviation. Collect a sample from the population and calculate the sample mean and the sample standard deviation. Fifth step is, calculate the t-value. Calculate the test statistic, that is t-value, using this formula. Sixth step is, look up the critical value from the t-distribution table corresponding to the chosen significance level and degrees of freedom. Alternatively, use statistical software to find it. Seventh step is, make a decision. Compare the calculated t-value to the critical value. If the calculated t-value falls in the critical region, or it is greater than the critical value for a one-tailed test, or falls outside the interval defined by the critical values for a two-tailed test, then reject the null hypothesis. On the other hand, if the calculated t-value is less than the critical value for a one-tailed test, or falls within the interval defined by the critical values for a two-tailed test, we can conclude that we fail to reject the null hypothesis. Final step is, draw conclusion. Interpret the results in the context of the problem and make a conclusion. If the null hypothesis is rejected, it suggests that there is sufficient evidence to support the alternative hypothesis, indicating a statistically significant difference between the means of the two groups. If the null hypothesis is not rejected, it suggests that there is not enough evidence to support a significant difference. Thank you for watching. Don't forget to like, share, subscribe and hit the bell.